Hello everyone. In this video, we are going to discuss the Prim's algorithm. Now, why is the Prim's algorithm used? A Prim's algorithm is used to find the minimum spanning tree for a graph. What is a tree? What is a graph? What is a spanning tree? Minimum spanning tree? All this we have discussed in the previous video. You can watch it for it in the playlist. Okay. Now, but let me tell you that only two conditions that we have to fulfill for a minimum spanning tree is that we should not have any cycles and the cost should be minimum, and then we have to include all the vertices and of the given graph. Only the edges can be eliminated or they can be mitigated, that is they can be left out, but all the vertices have to be included. Now for this graph, if I start to make a spanning tree, I'll find out. Suppose I start with node A, which I have taken as the root node. I can take any of the nodes as root node. I take A as the root node. So I start with A. A goes to two nodes, B and H. What I choose? B. Why? Because it has a lesser weight. So I choose B. I'll write on the weights later on. Then from B I can go to C and H. But why do I go to C? Because I have a lower weight at C. So I go to C. From C I can go to I, F and D. Since I has the lowest weight with it, so I go to I. Then I go from I can go from H to G. Now you see, if I go from I to G, what is going to happen if I go from I to G? What is going to happen? If I go this side, I'll have to form a cycle, which is not allowed. And if I go this side, H will be left. So I go from I to H, then from H to G, from G to F, from F to E, then from E to D. In this way, all the nodes are covered. Okay, and if I calculate the cost of this graph, it comes out to be, I have just simply written down the cost from here. It comes out to be the sum of all these costs, that is 43. Similarly, if I find out one more, this is one way I could have traversed the graph. If I find out some other way to traverse the graph, it could be that I would have chosen A, then B, then C, D, E, F, G, I and H. So in this way, 9, 10, 2, 6 and 7, the cost would have become 53. So out of these two, I would have chosen 43. But let me show you the weight of a spanning tree as 37 for the same graph. I'll find the weight of 37 for you people by using the Prim's algorithm. That is, every graph can have a number of spanning trees, but our motive is to find the minimum spanning tree. Simple spanning tree can be found by anyone, because there are so many different ways to cover up all the nodes of this graph, but we have to find out the minimum spanning tree. So that is the use of our algorithm. So we'll find out the minimum spanning tree using the Prim's algorithm. So for this purpose, what we have to do, we have to construct a table, you can say, which will have node containing the number of all the nodes, A, B, you can see the names of all the nodes, E, F, G, H and I. Then you are going to have the parent of every node, and you are going to have the key or the value of that node. Then you are also going to maintain a heap in the memory. It can be a heap, an array or anything, any data structure. You just have to mention all the nodes in it, F, G, H and I. So initially, every value has a cost of infinity associated with it. Infinity. Okay. And the parent is nil. No node has no, matlab every node has no parent. right? We don't know whose parent is whose. Now we start with our algorithm. Now obviously I'll have to what I'll have to do, I'll have to select a root node. I'll select the root node as A. As soon as I select the root node as A, I'll write down its cost as 0, and I'll do nothing with its parent. Why? Because the root node has no parent. What I have to choose is, I have to select the minimum of all the key values. The minimum of all the key values is 0. So I construct A. I have to keep on routing my graph over here so that there is no confusion in the end. So what I do? A. Now A is leading to B and H. That is, A is the parent of B and H with the cost of 4 and 8. So since A has been traversed completely, I will cut A from here also and the heap also. And A is the parent of B and H. So the parent of B is A with the cost of 4, and the parent of H is also A with the cost of 8. Right? Now again I will check out the minimum of all these values, 4, infinity and 8. Obviously I'm going to go with 4. So I make the next node as B and the cost was 4. So B goes to C and H. So the parent of C is B and the parent of H is also B with a cost of 11. But H is already having a parent A. So now we have to check this value. B is giving it a value of 11 and A had given it a value of 8. We always need the minimum value. So I will let the value be 8. Okay. And the parent of C was B with the value of 8. Since B has been completely traversed, we'll remove it from here and also from the heap. Now we check from the given values. We have C and H. Okay, both have 8. Matlab we have 8, infinity and 8. So we can choose any of them, that is C or H. It is my wish that I chose C. So when I chose C, C could go to D, F, I. So C was the parent of D with a value of 7, and C is the parent of F with a value of 4, and C is the parent of I with a value of 2. Now since C has been completely traversed, we remove it from here and we also cut it from the heap. Side by side we draw it over here. So C with value of 8. Okay, and so now what we do, now again we check these values. The minimum one is 2, that is the node I. So from C I will go to node I, with the cost of 2. Now I is going to, C has already been cut, so we are not going to consider it. I is going to H and G. It is going to H. H already has a parent, but A had given it a load of 8 and I is giving it a load of 7. I need to minimize it. So I will replace the parent of H as I with a load of 7, and I is also a parent of G. I is a parent of G with a load of 6. Now I has been completely traversed, so I will cut it from here and also from the heap, and I will go to the next step. Now after I am going to choose the minimum value here is F. So the parent of, so now that means I will choose F. The parent of F is C. Parent of F is C. That is, I will connect my graph from C to F with the value of 4. And since my F, it goes to D, G, C and E. C has already been traversed, will not take into consideration. I will take D. It goes to D with a weight of 14. D already has a parent C with a weight of 7. Since it is giving it lesser weight, we will not replace it. F is also going to E with a weight of 10. F is a parent of E with a weight of 10, and F is a parent of G with a weight of, with a weight of 2. As F has been completely traversed, we'll cut it from here and we'll also cut it from here. Now the next node that I take into consideration is out of 7, 10, 4, 2 and 7. That is, I will take G into consideration. So from F, now G is F's child. So that is from F, I have to go to G, okay, with a weight of 2, and G is going to F, I and H. I and F have already been traversed, only H is left. So what I'll check is G is giving a cost of 1 to H. That is, I'll replace the parent of H as G with the cost of 1, and I'll draw a node here as this. And since G has been traversed, I'll cut it from here and I'll cut it from here. The next node that will be traversed is out of 7, 10, 4 and 1. Obviously 1 because it is a minimum one. And H is the parent of A, B, I and G. A, B, I and G. Since all of these have been traversed, that is, I am not going to take any route from H to anywhere else. So H has no more role. That is, H is completely traversed, and I'll cut it from here. Now my leftover nodes are D and E. D has I'll start with D. Why? Because D has a lesser of key value or the cost with it. This is 7. Okay. So what I do, D has a parent C. Okay, D has a parent C. So I constructed it with a cost of 7. Now D went to C, F and E. C and F are already gone. Okay, so only E is left. That now E already had a parent with which was giving it a cost of it was F. I'm very sorry about this. This was F. So E had a cost of 10 with the parent as F, but now D is giving it a lesser cost of 9 with the parent as D. So I will choose this. So D is completely traversed. It is cut from the heap. And lastly, we make the node E with a cost of 9. And since E is also completely traversed, we cut it. Now since my heap is empty, so my algorithm is complete. Now let us calculate the cost. You can also check that all the nodes A, B, C, D to F to I, A, B, C, D, E, F, G, H, I, all the nodes have been traversed, and the number of edges, that is 1, 2, 3, 4, 5, 6, 7, 8. That is, I have vertices as 9 and number of edges E is equal to 9 minus 1, that is n minus 1 is equal to 8. It is satisfying our condition. And now let us calculate the cost. 4 plus 8, 12 plus 7, 19, 19 and 9, 28, 28 and 2, 30, 34 and 37. The cost becomes 37. So we were not able to find this cost with the normal methods that we were using. By using the Prim's algorithm, we found the cost of 37. That's all. Now let's have a look at the Prim's algorithm. So this is the algorithm for the Prims. For every edge of the graph, okay, first of all, I am setting the key values as infinity as I did. I am doing the this pi is the parent as nil, and the key value of the root as 0. And so this is my heap that has been maintained out of all the vertices until my heap gets 0. What I have to keep on doing, I have to extract a q. That is, I have to take out the minimum of all these values. Okay, and suppose when I take out the minimum that is stored in u, so for all the adjacent values of u, what I have to do, if that value belongs to q, that is, it is present in the heap and the weight at that value is less than the key, that is, suppose the weight of the weight that f was giving, the weight of e to f was more than weight of e to d, so we had replaced this thing. So what it has done, first of all, initialization of values, we maintained a heap unless and until my heap gets 0 or empty. What we do, we extract the minimum of all the key values. Okay, with that node that we get, we find all the adjacents. The adjacents here are v. If my adjacents are belonging to q, that is, they have not been traversed yet or they have not been pushed out of the heap, so what I will do, and I will also check that the weight that the new adjacent is giving is less than the weight already present. I will replace it and the algorithm will go on. Okay, so that's all. I hope you understood, and for any doubts and suggestions, you can mention in the comment section. Thank you for watching and do subscribe for more videos and thank you.